For the past year, I've been working on a real-life application that's currently in production, and I want to take you through the process and some of the key points of the application and show how you actually make a Xamarin Forms application and what comes along when you're building one. Already, we only just started. There we go. So a little bit about me. From Folsche, I'm a full-stack.NET developer. So anything related with .NET, basically that's what I do. Also a lot of front-end development. So on my back is still, you can ask me about front-end development. Last year I did a lot of presentations about it. This year I want to put my focus on Xamarin Forms. I work for Luminous in Arnhem. You can always send me an email or get in touch with me on Twitter. All right, so what we're going to talk about today. I'm first going to introduce the company a little bit and the application that we worked on, just to give you a little bit of context what we are talking about. Then an introduction to Xamarin, because, well, this presentation is about Xamarin Forms, but it's built on top of Xamarin. It's very important to introduce that a little bit. Then we will go into unit testing, see how easy it is and what you can accomplish with this and how it works. A little bit about release management. All right, we have an app now, how we get it into the stores. I want to show you a little bit about analytics, how we implemented this and what we do with that. And if there's any time left, I'll show you a little demo how we implement a new feature in a Xamarin Forms application. All right, start off with the company and the app. You don't need to know much about it. It's basically a wholesale application company that I was working for the past year. They sell technical equipment, like heating and ventilation equipment. To give you a rough estimate about the company, they do around 40,000 orders a month, 150,000 articles, and have 20 service points in the Netherlands. The application I worked on is basically an update of an already existing application. They used to have 3 native applications, and they were looking for a way to update those, and they were looking at a new application to be easier to maintain in one code base. Basic features application are basically water heater maintenance or boiler maintenance. So you have a water heater, the maintenance guy comes to your home, wants to know what water boiler you have, what parts are in there, what can be wrong with the application, what error codes are appearing. So if you have a code like 01, you can look up what it actually means. And then when you found out what's wrong, you can order the part through the app. That's basically it. The original application was already available for iOS, Android, and Windows, so that was one of the requirements for the new application as well. All right, so Xamarin. Well, let's first go into a little bit what the options are if you want to make a cross-platform application or want to make an application in general. I've put these main choices on the screen here. We start off with native. Obviously, you can create a native application which gives you building the application like Apple, Google, Microsoft intended it. I think maybe there's a lot of resources available for those ways. You can get a lot of done, but you have to write those applications separately from one another. If you want to do code sharing, web-based is one of the options a lot of people use. There are a few downsides to it. Your UI will probably look exactly the same on each device, or you have to program a lot to make it different. It will never be as responsive as a native app, and some other few things. Then there's Xamarin. What Xamarin actually does is expose the APIs from Android, iOS, and Windows, or Windows already C#, but into a C# API. So you can call upon the native APIs from C#. So let's say you have a flashlight function. That flashlight function is going to be called exactly the same as it would be in Objective-C, but now you're using C# to call upon that function. So that's basically what Xamarin does. And the user interface for Xamarin, you still make using the traditional interface languages depending on the platform. So on iOS, you probably use it from Code Behind or storyboards. And from Android, you have your XML layout language. And for Windows, you probably use XAML. Now, what Xamarin Forms does is it takes it to another level, and also sharing your UI logic and your UI of your application. So you define your application once in XAML, and you share that across all the platforms. And we go dig into that a little bit deeper. All right, so back to Xamarin. What else I'm going to do? Like I already explained, it exposes those APIs. So what you see here is your shared app logic. What you can do with this is write all your business logic, the way you retrieve your data from the server, the way you send it to the server, what pages are represented, all in C#. On top of that, you have platform-specific projects. And those projects contain code that only work on one platform. So on iOS, you might decide how to turn on the flashlight, for example, because it just works different than on Android. So the part here is all shared logic, and those three little blocks are platform-specific logic, but still written in C#. When you compile this, it depends on the platform what actually will happen. On iOS, they don't allow any runtime, so this will compile directly to machine code. Be run on the iOS device. For Android, they're actually using the mono runtime, so your C# code will compile to intermediate language. They will run on the Android device in a compiler, and obviously for Windows, it's a native compiler on the platform. All right, so we can develop with C#. How would this look like? Where are you programming this? You have two options, Windows or Mac. I'm a Microsoft developer, so for me it's very tentative to use Windows, but it has one big advantage, in my case a necessary advantage, is that you can only make Windows application on Windows. So for me, I choose the Windows version. If you only want to do iOS or Android, you can use all the macOS tools. All right, so we have our Windows platform. Running on top of that, your programming environment is Visual Studio. So within Visual Studio, you can program for Android, iOS, and Windows. Then there's one interesting part, is how you're going to develop iOS on a Windows machine. Oh, wait, one step back. So here I have a snippet of my Visual Studio solution. Basically what this is the solution file up here, which is basically a collection of projects. The first project is a shared application project. We have all the shared code. Here you would want to write about 80% of your code. Then you have three projects, Android, iOS, and Windows, that have that platform-specific code we talked about earlier. And obviously we have a test project. Okay, back to the iOS story. How are you going to run iOS on a Windows machine? Well, you can't build iOS on a Windows machine. You need a Mac. So in this case, in my office, I have a Mac Mini on my desk. And what Windows actually does, or what Xamarin actually does, is creates an SSH connection to that Mac and actually builds the application there. That's also where the emulator is running and where you will have your devices connected to when you want to debug on a specific device. So when you press play in your solution, this will actually start, in this case, a simulator on the Mac, and you can just debug in Windows, but the application is actually going through all the steps on the macOS machine. All right, a little demo of how this works in practice. So what I want to show you, I have a project, I have a file here. We go in more detail about how you structure your code later. But I actually have the application now running, and it runs on my phone. So this is actually my phone here, and I have the screen mirrored on my PC. There it is. So this is the application, it's running at the moment. And I set a breakpoint in the part that manages the brands in the application. So now when I click on brands, stuff should happen. There we go. So actually now I clicked on my phone on the application, so breakpoint will go off of Visual Studio. And actually now I'm debugging the code that's running on my phone. So here I can just step through all the lines. I see what dependencies I'm getting injected. So here I'm setting a property. You can see this property now has values. And I can also step into functions, just like you would normally expect from a normal .NET project. So if you press continue, it actually load the screen on, in this case, Android. This will work exactly the same on iOS and Windows, but I didn't bring a Mac and all that stuff here, so I'm mainly doing the demos on Android, but it will work exactly the same on a Mac and on iOS. All right, so we explained a little bit what Xamarin is. So what does Xamarin Forms add? If you take the picture we had previously here on the left, we can see that now a lot more code is shared, and specifically this part. So also the UI logic. So you define UI once and run it on multiple platforms. You will still have a little bit of platform-specific code to make some exceptions on what's available. Let's say you have a button, but you want to default a button is round. If you want a button square only on iOS, you will probably want to do that in the iOS project. So to make exceptions on the general rule, general UI layer, you probably want to do that in this platform-specific project. All right, so how many are going to go about structuring your application in Xamarin? Specifically Xamarin Forms. With Xamarin you can do whatever you used to on the specific platform. For Xamarin Forms you're probably going to use MVVM, which is Microsoft preferred structure of structuring your application. Start off with models. You can see them here on the right. They basically contain your data, maybe some business logic if you're posting a lot of stuff back to the server. Very simple class. Then your view model, which has all your logic. What happens when you click on a button? When are you navigating to a page? When is something visible on a page? When is data retrieved? This logic is all in your view model. And then you have your view, which is totally separate from your business logic and contains where buttons are placed and how many buttons and where is a list, etc. From the view you can communicate back to the view model using commands, and your data will be data bound. View data binding, so data on your view model is available in your view. I've simplified some snippets of the code, but actually in our application we have a brands class. It looks pretty much like this, just has 3 properties, and this is our model. Here we have the view model, which contains a little bit more logic. Also, this is a little bit simplified, but it's basically the same as what's currently in the application. What you see here is a list of brands, which is wrapped in another class. We have a page title which we define in the view model. Maybe we want to add a translation framework later. We can do that here, and the view won't notice anything. Here we have a command. What happens when you click on one of those brands and you want to navigate to the brand-specific page? And here we have the view. Also a little bit simplified, but here you can really see all those properties. They're on the view model. So it's just the page title, which is bound to page title object. We have the brands, which is used here to populate the list. And we have this command, which is referenced here. So you have a very loose coupling between your view logic and your view model, where your application logic is located. This is using XAML, a specific XAML implementation that Xamarin made for Xamarin Forms. But we use the same standards, the same techniques, the same syntax. But for example, the list view element might not exist in other XAML technologies. All right, digging into a little bit deeper, how will this XAML will be rendered on the page? It really depends on what platform you are. In this case, we have a tab page. Before we have a content page, very simple page. This is a tabbed page. And the tab page is rendered differently on each platform. So on the right you see iOS, which usually has the tabs on the bottom of the screen. So actually Xamarin will take care of rendering it in the position that iOS users are familiar with, and we'll use the native components that are available for that platform. On Android you have the tabs usually at the top of a list, and on Windows you have a similar thing. So Xamarin Forms really takes care of rendering your application in the way the user would expect that on the specific platform. All right, so now we can put UI stuff on the page and it will be rendered. But what if we want to run platform-specific logic? In our case, I'm going to run through this a couple of times. We're using Google Analytics, and Google Analytics is available for Xamarin, but not for Xamarin Forms. So every implementation is slightly different on each platform. So we have a Xamarin Forms iOS implementation, Xamarin Forms Windows application, and Android implementation. What I've done is I've made a wrapper so you can use call once from your shared code any of those implementations. So let's have a look at this. What you do is you create an interface. This interface defines what's possible and what you want to have executed. So in this case, we have a Google Analytics service, which has one function that tracks what page you're on. All right, next up is we need to get that dependency somewhere in our shared code. So when we're running on Android, we run the Android implementation. When we're running on iOS, the iOS implementation. This is quite easy. You just get the implementation by calling the get method on the dependency service using the interface. So now you have the implementation, you can call the track app pages, but you need to have, obviously, an implementation somewhere. So this is the implementation simplified of the one we have for Android. It's just implementing the class, and here's implementing the function. Basically uses the GA tracker, which is a Xamarin plugin. And here, using the assembly tag, we let Xamarin Forms know this can be used with the dependency service. So when we're running the application on Android, this function gets called, and this implementation gets run in. So when we run Android and call this function from our shared code, we actually track that page on Google Analytics. All right, a little bit about unit testing. Actually, I was planning on doing a lot about unit testing, but it's actually very simple. It's just exactly the same way you do unit testing for the .NET platform. You can use almost all the libraries, all the tools that are available. So there's probably going to be Visual Studio, including using MS Test. Here's one of the test methods. I want to actually implement one in our application. So we have the app running. I'll stop that. All right, so we have our shared code, our Android project, iOS project, so this is our test project. We were looking at the brands page earlier. So I have a bunch of tests here, but I'm still missing one test, so I want to add one. So I'm annotating a function with the test method. This is just a way telling the framework that I'm going to use this as a test. So brands page title. I want to make sure that the brands page title is set correctly. Obviously, I need to get a new instance of the thing I want to test. In our case, it's the view model. Obviously, we'll have a few dependencies, what we saw earlier. It needs a way to communicate with the server, the Google Analytics provider needs to be injected. What I'm doing is using an existing mocking framework called mockq, and I'm just mocking those classes that I need in my application. Here's another one. That's my Google Analytics mock. All right, so I'm giving those the implementations it created for me. This will make sure I don't get any weird errors, that it will get null reference exceptions if I pass in null here. All right, so we have a view model. We need to create a test. We rather assert r equal, and the thing we're actually expecting is, let's say, brands page. And let's see if that matches with the existing page title. All right, save this. I just run this test. Needs to restore some dependencies, apparently. So there we go. Well, it fails. Obviously, it fails because in my project it's not called page brand page, but it's actually called differently. So let's change this to brands page, and we can run the test again. And now it should be green. Fingers crossed. It's a bit slow today. Uh-oh. Always be careful with updates. Since the last update, for some reason, my build sometimes fails. I have to clean the solution. I still have to dig into it, what it is. But we should have a running test, and it's actually green. Great. All right, back to the slides. All right, unit testing, just the way unit testing is always done in .NET. Release management. All right, we have an application, we have great logic, we all wrote it in the view model, we have nice pages, we tested everything. So I think now it's a good time to release the app. It depends a little bit on the platform you're on, how you release it. I think Android definitely has the best support currently for Xamarin Forms. So what you see here is basically an overview of all the packages I created. You can just create this from the menu and it'll create a package for you. You need to make sure obviously the version is set correctly. All right, so now you have this package. You basically click here on distribute. We'll open a dialog and you can choose. Do I want to make an APK file and put it on my disk and do whatever I want with it, maybe distribute it internally in my organization, or do I want to publish it directly to the Play Store? So I chose to publish it directly to the Play Store. I need to select a certificate I want to sign it with, and I need to link my Play Store account using their API to Xamarin Forms. Xamarin in this case. All right, and I can choose when I want to publish the beta channel, alpha channel, release channel, even a percentage of my users in production. And then press upload. That's it. Now the application is actually in the store, and we have it set up so our tester will automatically get a push notification from the alpha channel, so he can start testing the app. So it's all from Xamarin, from Visual Studio. All right, how does it work on iOS? To a certain point, you can do this on Windows, so you can build the file for production, get it to be on the server. But in the end, you will still need to get on your Mac and use the tools from Apple to actually publish it to the store, like you would have to do with any iOS application. So what we're running here is Visual Studio for Mac. It actually, this was still the preview version. I think it released a few days ago. So now the production version of Visual Studio for Mac is also available. Before you had Xamarin Studio, but now Microsoft has bought Xamarin. They changed it into Visual Studio and added some more features. Basically the same. So here we have our list of packages, and we click Sign and Distribute. A similar option, we can do ad hoc or App Store. Okay, we're going to choose App Store because we want to publish it directly. It gives us a little bit of overview what certificate we want to use, what distribution profile we want to use. And that's it. You click Publish. Unfortunately, it won't publish it directly to the store. It put an IPA file on your machine, and you can open the application loader. In the application, you have to select a file, and it will publish it to the Apple Development Portal. And then in the Apple Development Portal, you still have to select to which testers group you want to publish that build to. And I think you have to agree with some policies, stuff like that. I'm not going to go a little bit more into Windows. For Windows, it's not the same flow as you go through with iOS and Android, but it's basically exactly the same flow as you would do for a normal Windows application, which you can create the app packages here and then upload them to the Windows Development Portal, which will look about something like this. All right. I want to show something nice we added to the application to illustrate how the application actually works in real time. You can actually download the app from the store. We can do a little bit of an experiment with it. Because it's now in the store, you can also search for Service Riser, and you should be able to find it if you want to participate. So we added Google Analytics to the application. We used 3 different Xamarin libraries. What makes it great that we're using Xamarin Forms, and why I'm showing this example, is that we're using Xamarin Forms. All our pages are exactly the same structure, and they should have exactly the same content. So that the tracking across the pages is exactly the same for every device. So very interesting to see what difference there still are on each platform. Because the tracking, the page is open exactly the same time, it's defined at the same moment. We only define the title of the page once, so you don't make any typos between the 2 products. It makes for very consistent tracking. One of the interesting things we found, on the left you see our user group. So a majority of our users is Android, a lot of iOS users, and this little thing is our Windows user base. So I think Microsoft has some work to do. On the right, you can see the screens per session. So how many screens does a user typically open on each session? You can see it's only a small difference, but iOS users tend to open more different screens than Android users are. Well, I'm not the analyst at a company, but I think it's an interesting statistic, and you could find out why it actually is. An even more interesting thing is that here we have the orders per 1,000 sessions. So we can see for every 1,000 sessions, an iOS user will do about 25 orders, but an Android user about 17, I guess. So for some reason, iOS developers on our app are more likely to buy stuff than our Android users. I think Windows is not really representative at this point because it has such a small user base, but something for our data analysts to find out why iOS users are more likely to buy stuff. But maybe this will decide for us to target iOS more or put more effort in our iOS application. All right, so I hope you guys opened the application. What I wanted to show is also that we can now track in real time how many users are actually currently using the application. So usually throughout the day we have about 6-7 users are actually using the application right now. I think around 700 are using it on a daily basis. So what we have here is a shared analytics for all the 3 platforms. So we don't distinguish Android or iOS, we can, but you don't have 3 different analytics portals. It's all shared in one. You can see exactly what's going on with the application. So currently there's 9 people using the application. So if you start up the phone, you should see the number increase, I guess. So yeah, for us it really helped, and now we are looking at what we can do with the data. All right, the last item on the slide is a demo. I'm not sure why I'm going back to the slides, but I want to show you how to implement a new feature in our Xamarin Forms application. I hope this all goes well. What I want to do is add a battery plugin to my application. So let's say I want to show the battery on a certain page. What you would typically do is using NuGet, which is the package manager for any .NET project. So I will search for battery plugin in this case, and I found here a battery plugin. I already checked this online, and it's available for Xamarin Forms and for all the projects I'm using. I have to install this in the shared library and on each platform, but not on my test project. All right, let's install that, and I hope the internet is working. So it's getting the files now of the NuGet servers. I think in the new .NET Core you can also get your dependencies from other sources. Let's see. Still loading. And as a plugin developer, you can choose which platforms you support. So let's say you're only running Android and iOS, but you still want to make your plugin available for all the users. You can only make it for Android and iOS. So you have to write those implementations and make a shared interface that you can call from your portable project. Okay, seems like it's done. Obviously, we want to put our logic in our view model. So we will start off with our view model. What I want to do is check the percentage of the battery and add a percentage mark to it. So we start off with a property. We want to return a string, not a static. I want to call that battery percentage. We only want to get this property. And we want to return something. The plugin is called cross battery, if I remember correctly. And so now we can get the current instance of this. Probably you want to get this through dependency injection so you can actually test it in your project, your test project, but for now this will do. And we want to get the remaining percentage, and we just postfix that with a percentage mark. Make it look a little bit prettier. There we go. All right, so now we can have some functionality implemented in the view model, so now we're going to get it on the view. I'm implementing this in the setting page view model, so I probably want to go to the settings page. There it is. I will put it a bit on the bottom. We have a place here, so that's the label here. So what we want to do, we want to make a label and bind the value that we got in our view model to the text value of that label. So we get a text property, then we use the binding syntax. What we want to bind to is actually a property name. That should be it. Let's see if it actually works. It might take a minute. For some reason, I think this viewing tool is really slowing down my PC. I've checked the response times last week. I think on iOS we got about 30 seconds between it shows the start screen on the emulator when they're running on iOS. And for Android it's usually about the same. Mainly I'm doing my primary development on Windows because it just starts up natively on my machine. So it's always that much quicker. So I'm implementing a feature first on Windows, and afterwards I'm checking if it actually works on Android and iOS too. Come on. It's actually nice weather today. Not sure if you noticed sitting inside, but come on. I should have shown it on Windows. It would have been a lot quicker. Maybe have some time to. We still have it. You can see how our Windows application actually looks like compared to the Android application. So it's a Windows application that does run on phones, but also on desktops. So people who are servicing their water heaters using a Windows tablet, they can also use the application, which is not starting. There we go. As you see, it's fairly similar. What we've done on tablet devices, the only thing we changed is that we open the menu by default. And what Xamarin Forms does is stuff like the search bar here on the top left that will look very iOS on iOS, and on Windows we use the standard Windows search bar. Let's see, I have the battery plug-in version here. Yeah, actually I have the version installed that has the battery percentage. So this is the thing I just added. And actually my phone is timing out because it takes so long. Maybe we come back to that in a little while. That's basically the end of the presentation. A few more things I want to say about the difference between Xamarin Forms and Xamarin, and when do you want to use one or the other. What I've noticed is that Xamarin Forms is great to also share UI logic, but if you want to have very specific UI elements, pay a lot of attention to the design of the application, you're probably better off using Xamarin because you will rewrite a lot of those UI components anyways, because maybe you want round corners, you want this different, that different, and then you end up overriding all of the default classes that Xamarin Forms actually creates. So if you're having a large-scale project, you probably better off using Xamarin. But if you have less picky stakeholders, I guess, I think Xamarin Forms could work very well for your default CRUD applications, stuff like that. Well, I only talked about good stuff about Xamarin, and I did this presentation earlier, and they said, oh, you should also talk about disadvantages. Obviously, there are quirks, and sometimes you get into strange issues. And you are dependent sometimes a little bit more on Xamarin Forms than on Xamarin, on developers Xamarin. Actually, there is a slight delay if you look at Xamarin when iOS is released and when Xamarin is released, but usually this is one day after the iOS release, there's a new Xamarin release. And I think there are quirks. Sometimes you have issues deploying or there's something wrong, but to be honest, I think you will have the same thing if you're making 3 different applications and want to maintain 3 different environments. A great thing is maintainability, so I think that's a big plus, the main reason why you should do Xamarin. And the conclusion of the project is basically we worked on it for about 1 year with 1 FTE. Different people, but about that time, and we got about 80% code sharing done, and we developed 3 applications. I'm a little bit over time, I saw.
Yeah, 5 minutes.
So yeah, if you want to have any questions, ask them now or email them to me. You can vote at the end of the presentation, and my company Luminous has a stand. I will be there after the presentation if you have any more questions or you want to talk about any random topic or enjoy the beer. I heard there are some. That's it. Any questions? Yeah.
Is Xamarin Forms available in Visual Studio community?
Now I think yes. So now it's bought by Microsoft and made it available free in the Xamarin community version, yeah.
And also Visual Studio for Mac, or what's called?
I'm not actually sure. Xamarin, one of the big advantages for Xamarin was that it was very expensive to have, and now it's bought by Microsoft. You only need to have MSDN license. I think you can still also do it without. So it's definitely become a lot cheaper, but I'm not sure if it's 100% free. I think so.
As for the case when the development is done with Xamarin, not Xamarin Forms, when there are projects for each platform, are there any restrictions on the code sharing part so it can be executed on every single platform?
Yeah, basically 2 options for your portable project, the shared code project. You have an older version which is called a shared project, and basically you can run anything you want, but you have to consider yourself whether those APIs are available. What I'm using now is a portable class library, which only supports the APIs that are common on all the platforms. So the more platforms you add, I think you can also add macOS. A little less APIs will be available to use. But obviously you can implement those APIs natively on the platform and use an interface to call upon those. Yeah.
Thank you.
Welcome. No more questions? One more?
Xamarin Forms supports all type of gesture.
Gestures?
Gesture.
I haven't worked with gestures much. You can do gestures, yes. I'm not sure about all the type. Like I also said, if you want very, very specific UI things, you probably want to have slight differences between Android and iOS as well. So if you really want to have a gesture-intensive app, maybe Xamarin Forms, but I think you should look at Xamarin more in that case, yeah. So maybe if you want to slide open the menu on the left, that should be fine, but making it more complicated, you probably want to switch, yeah.